Welcome back. In this video, we're going to do an example. The question is, does the parabola have a tangent line whose slope is -1? And if that does occur, if so, we are going to find an equation for the tangent line at that point and state that point or the ordered pair. All right, so all we know is we want the tangent line to have a slope of -1. What we want to make sure that we understand is that slope is a rate of change, and the derivative gives us the slope of the tangent line at that point. So in order to do this problem, we're going to need to find the derivative. Once we've found the derivative, we're going to set it equal to -1, because remember, the derivative represents the slope. So we'll solve, if possible, to see if there is an x value where the derivative is equal to -1. All right, so the function we're dealing with here is y equals 2x squared minus 13x plus 5. Our first step would be to find the derivative, dy dx, and I'm going to use my formal definition of a derivative. So that's going to be the limit as h approaches 0 of, my first part is going to be f of x plus h. So that means I'm going to plug an x plus h in for both of those x values. That gives me 2x plus h quantity squared minus 13 times the quantity x plus h plus 5 minus my original function using parentheses 2x squared minus 13x plus 5, all of which will be divided by h. So simplifying, I've got the limit as h goes to 0. That would be 2x squared plus 2xh times 2, 4xh, plus 2h squared, minus 13x, minus 13h, plus 5, minus 2x squared, plus 13x, minus 5, all of which is divided by h. So 2x squared minus 2x squared, negative 13x plus 13x, and positive 5 minus 5, those are all going to cancel. As I've mentioned before, most of the time, especially if it's a polynomial, all of this second piece is going to cancel. All of the original function should cancel out. So my derivative, I've got the limit as h approaches 0, 4xh plus 2h squared minus 13h over h. You'll notice here that all of my terms have an h. All of the terms in the numerator have an h, so I can factor that out. 4x plus 2h minus 13 divided by h. Those h values cancel. I have the limit as h approaches 0 of 4x plus 2h minus 13. At this point, I can plug 0 in for my h, and I have 4x plus 2 times 0 minus 13, or 4x minus 13. So the derivative of x with respect to y is 4x minus 13. That represents my derivative. And remember, the derivative represents the rate of change. So, going back up to the top, we said, does the parabola have a tangent line whose slope is -1? So the derivative is my rate of change or slope. I'm going to take that -1 value and plug it in for my derivative. And whatever I solve for, this is going to let me know if I do have a slope of -1 where it occurs, at which x value. You could end up with a situation where you cannot solve it here, and that would mean that there is no x value. If you worked through this and you were getting an imaginary number or something that was undefined. In this case, I'm going to add the 13, that gives me 12 equals 4x, and divide by 4 on both sides, that gives me 3 equals x. So to answer the first part of our question, yes, at x equals 3. At x equals 3, the graph of this parabola, the slope of the tangent line is -1. And if we thought about what the graph of this looks like, this is a parabola opening up. It should look a little more smooth than that, but x equals +3 is right about there on my parabola. And at x equals +3, the graph has a slope of -1. M, my slope, would equal -1. All right, so we still have another part of this question. We want to find the equation of the tangent line at that point and state the point. So in order to write the equation of the tangent line, remember we were given the function y equals 2x squared minus 13x plus 5. Find the equation of the tangent line at x equals 3. So in order to write the equation of a line, we need a point and a slope. The point is easy enough for us to find. The point comes from the function. The point comes from f of x. So my point, 2 times 3 squared minus 13 times 3 plus 5, the output we get there is -16. So my point is at 3, -16. That is my point. So we already know what the slope is. The slope is the derivative, and the derivative was given. It was -1. However, if we take our derivative formula, 4x minus 13, right? We've got y prime equals 4x minus 13. If I were to plug my 3 value in, y prime, I would get 4 times 3 minus 13. I get out -1. So m equals -1. Of course, that was given. So using my point-slope equation, y minus y1 equals m times x minus x1, I'm going to determine that the equation of my line would be y, we'll get minus -16 or plus 16 equals -1 x, and we'd have minus 3. So the equation of my tangent line, that would be -x. I'd have plus 3 when I distribute, and I subtract 16 from +3. That gives me minus 13. So the answer for the equation of my tangent line at that point is y equals -x, take away 13. All right, so we answered kind of a conceptual question about derivatives. And that's it for this video, so please make sure you email me if you have any questions.